Hello everyone, I am Priti Tikkas, lecturer of Electrical Engineering Department A shift of Praveen Patil College of Diploma Engineering and Technology. Next topic of the distribution line is numerical or example based on the distribution line. So let's see. First numerical. A pole and a stay assembly as shown in the figure are to be erected. Determine the value of excavation required to be done and also draw a list of material which will be used to provide such an arrangement. So first calculate the total volume of excavation. So how to calculate it? So it is equal to excavation for the stay pit plus excavation for the pole pit. So excavation for this stay pit is equal to 0.91 into 0.61 into 1.22 is equal to 0.677 cube meter. Then excavation for the pole pit. So it is 0.91. It is already seen here 0.91, that means this is the centimeter which is converted into the meter, 91 centimeter which is converted into the meter, and this length and breadth, this is the length and breadth. So 0.91 into 0.61 in bracket 0.60 plus 0.75, 0.60, this is 0.60, then this one 0.75 and 0.45, so 0.45 is this one. So this is the total pole pit. So it is calculated in the cube meter is 0.91 into 0.61 into 1.80, 80 is equal to 0.9991 cube meter. Then the volume of the excavation. So volume of the excavation is equal to stay pit into the pole pit. So stay pit is 0.677 plus 0.9991. So calculated is 1.6763 cube meter. It is the total volume of the excavation. Now volume for the PCC block is to be provided. So volume of the PCC in the stay plus volume of the PCC in the pole. So stay and pole, stay this and this one is the pole. So total volume of PCC is equal to, first calculate the PCC stay. It is 0.91 into 0.61 into 1.22 is equal to, that means calculation for this. Then calculation for the pole. For pole 0.91 into 0.61 into 0.60 minus volume occupied by the pole. Now assuming the pole has been, the area of cross section is 0.23 into 0.23 square meter. The volume of the PCC in the pole is equal to 0.91 into 0.61 into 0.60 minus 0.23 into 0.23 into 0.60 minus 0.15. Now after calculating 0.3331 minus 0.02380, so total total volume is 0.3093 cube meter. So total volume for which 1:4:8 PCC is to be provided. So the total volume is 0.67. This is the PCC. 0.672 plus 0.3093 is equal to 0.9865 cube meter. Now volume of cement. So volume of cement is equal to 1 upon 13. 13, that means 8 plus 4 plus 1. So it is 30. So 1 by 30 into 0.9865. So volume of cement is 0.0759 cube meter. Now 1 cube meter cement contains weight is 2060 kg approximately. It is the assumption. So weight of the cement is, total weight of the cement is 2060 into the volume of cement is 0.0759. It is 156.35 kg. Now volume of sand. So sand is used for the 4 divided by 13. So 4 by 13 into 0.9865, it is 0.3036 cube meter. Then volume of 28 mm graded stone or brick aggregate. So it is 8. That means this ratio which is for the 1 for cement, 4 for sand and 8 for bricks. So 8 are the bricks. So total is 13. It is 8 by 13 into 0.9865 is equal to 0.6072 cube meter. Total volume of the brick work is equal to total volume for the first step plus volume for the second step and the minus of volume of pole. So it is 0.85 into 0.55 into 0.75 plus 0.79 into 0.49 into 0.45 minus 0.23 into 0.23 into 1.20. So it, after calculating, 0.4613 cube meter. Assuming the 500 bricks are used for the 1 cube meter volume. So number of brick required. So 500 into 0.4613. So it is 230.65. That means 231 numbers of bricks we have to required. Now assuming the 95 kg cements is required to provide the bricks work with cement, sand and having ratio is 1 by 4 for 1 cube meter volume, or which the 500 bricks. So weight for the cement required is 95 into 0.4613. So it is 43.82 kgs of the cement required. Then sand, the volume of the sand required to provide 1 by 8 bricks machinery. So 43.82 kgs divided by 2060 into 4. So approximately 0.0866 cube meter sand is required. So total quantity of the cement required for providing PCC or the bricks. So it is equal to 156.35 plus 43.82 is equal to 200.17. That means 210 kgs we have to required. Then including the quantities required for the plastic and the top surface of the brick and machinery. So total quantity of the sand required for PCC block and the bricks machinery 0.3036 plus 0.0866 is equal to 0.4 cubic meter. So including the quantity of the sand required for plastering the top surface of the bricks machinery. So these are the total list of the material. PCC pole required 1, stay pole 6.30 mm thick and the 30 cm by 30 cm in size with 19 mm diameter hole. It is 1. Galvanized stay and anchor rod 19 mm diameter 60 cm long. It is 1. Then stay bow of the galvanized iron is 11 mm diameter and 37.5 cm long. It is 1. The galvanized thimble is 2. Then stay insulator 1. Stay collar in 3 mm thick flat iron is 10. Then stay size is 7 by 8. 7 by first 10 of the GI. The wire of size is 8 SWG. So taking the length is 7 meter approximately. MS bolt and the nuts having the round neck and hexagonal head 50 mm by 15 mm. It is 2. Then MS washer 15 mm, 2 cement 210, sand 0.4 cubic meter and grinded stone or the bricks aggregate of size 28 mm. So it is 0.6072 cubic meter. So these are the description of the material. Next numerical is connection of 1 MVA transformer is to be given by the 11 kV 3-core underground cable. The length of the route is 1 kilometer up to the transformer. Prepare the list of the estimation for this work. So solution: a very fast job to calculate the full load current of transformer, the same current through the feeder line, and then finding the suitable cable from the stranded cable. So full load current IL is equal to load in kVA divided by root 3 into VL. So 1 into 1000 divided by 1000, that means 1 MVA is already given. So 1000 divided by root 3 into 11 kV is also given. So 11. So it is 52.5 ampere. Now suitable cable is carried which much current from the stranded table is 1 by 3.55 mm. Now selection. Next, hire to the 7 by 1.70 mm size. The specification is aluminium core, PVC insulation, heavy duty, 11 kV 3-core underground cable of the 85 ampere capacity is to be selected. Now description of the material. So aluminium conductor we required, PVC insulated heavy duty 11 kV 3-core underground cable. It is 1000 plus 30 in a meter. Then junction box, complete the junction material 7 by 1.70 mm aluminium conductor is 4 numbers. Then joining cable for 11 kV end box. Then outer pole mounting cable end box 1. Then GI pipe for carrying cable is 5 meter. Then different types of clamping which required 8 numbers. Cable joint maker is 4. Then civil work sand, that means 100 cubic meter. Then bricks 16000 numbers. Then crossing road stone pipe is 15 meters. So knowing the market rate, adding unforeseen charges, labor charges, sundry and the costing table can be completed. Next is overhead distribution line. Overhead distribution lines of 440 volt 3 phase 50 Hz is passing strength 300 meter in the city along the road size. Taking the span of the 50 meter, estimate out the material required. Give the details in the tabular pole. Draw the pole and show the wire connected through the shackle insulator at start. First, calculate the length of wire. Length of line is 300 meter. Length of line is 300 meter. It is given. Then distance between poles, that means 50 meter is the span, is also given here. Then 300 meter is also given. Now calculate the number of span. So each span, tabular pole having the each span between the two pole span is 50. So 300 total length. So 300 divided by 50. So total number of span is 6. So required 7 pole, 6 span plus 1. It is required, the number of pole is 7. Then ACSR conductor. So 300 meter into 4 wires is equal to 1505 meter. Then into 3 is 3600, that means 3800 meter including the sag. Then insulator required 10, 5 into 2. So then pin insulator is also required 5 into 5. So these are the 25 pin insulator and 10 shackle insulator. So this is the drawing of pole or assembly of pole, conductor and insulator with stay wire. So this is the stay wire. These are the different wires R, Y, B and SL and E is the earthing. So this RYB is the phase wire, E is the earthing wire. So this is the diagram for this, and material required for steel tabular pole 7, ACSR conductor wire is 3800 meter, 5 meter extra. Then ACSR straight light wire is 300 meter, earth wire is 8 SWG GS galvanized steel. Then shackle insulator we want 10, pin insulator want 25, and GI clamp is 8, stay GI wire is 4 numbers. Then stay insulator 2, reel insulator 2 on each span. So it is 12. Then LT cable joint with fitting is 1, nut bolt lump sum, I screw bolt is 2, street light complete with fitting is 6, civil work, that means foundation for pole is 7 numbers, 7 foundation is there. Then danger plate is 7 because it is a high voltage line. Then miscellaneous lump sum. The rate are to be day by day changes. The costing can be completed with respect to the rate in the market. So this is the list of the material for that. Thank you.